So today we're going to do an extension on exponents. So first question I have for you is, what is the answer to that simplified? Yes, Jesse?
X to the power of a times b.
Okay. You multiply exponents if you have a power to a power. Any questions on that? Next question I have. What's the answer to that question?
0?
No. 3 times 0 is not 1.
I was thinking the implication.
And 3 divided by 0 is undefined.
I'm sorry.
Anybody know the answer to that question? It's actually a mathematical property you are required to know. A number times its blank is equal to 1.
Oh.
What?
1/3.
Which is called its what?
Inverse.
Oh.
That's not its inverse.
Oh,
I was
okay.
thinking
I get it.
Starts with the letter R.
I knew it. I was just
Reciprocal.
Gotcha. 0.
Okay, this is called the identity property of multiplication. Well, kind of. This is the inverse property of multiplication. What it does is it gives you the identity number for our number system, which is 1. So next thing I want to ask you, what's the answer to that? 16. How would I undo squaring a number?
square rooting.
Square rooting a number. What is the square root of 16?
4.
So what is the square root of 4 squared?
4.
4.
Oh.
Okay. Today we're going to talk about roots actually being exponents. So remember at the beginning of the year when we did order of operations and we did grouping symbols first? Mm-hmm. The next thing I said wasn't just exponents, it was exponents and roots. And then I said later on this year we're actually going to turn those roots into exponents.
So exponents.
So the question I have is, right now we have 4 squared raised to a power is equal to 4. Well, what power is 4 just to be a 4?
1.
4 to the first. So what number do I have to multiply 2 by to get to 4?
1/2.
There we go. A square root is raising something to the 1/2 power. A square root is raising something to the 1/2 power. What do you think raising something to the 1/3 power would be?
Cubing it.
Cube root. Cubing it would be raising it to the 3rd power.
Sorry.
So raising it to the 1/2 power is something squared because is the square root, and it makes sense because 2 times 1/2 is 1. And you guys, I didn't tell you. You guys are the ones that told me the way you undo something squared is take its square root. So they have to mean the same thing. So that's where we're going with this today, is fractional exponents. They have the exact same properties as regular exponents. If you have 2 things with the same base multiplied by each other, you're going to add exponents. And that's the reason why they taught you fractions back in elementary school. It wasn't to do cookie bar problems or candy bar problems. It was so that when we got to exponents, you could actually add the exponents as fractions. There's a reason why they teach you fractions, and it's not just to do money and how many pieces of slices of pizza that can you share between your friends. It's to develop the skills you need to do this. Okay, you need to be able to add, subtract, multiply, and divide fractions basically on a piece of paper without a calculator. So the fractions we are going to deal with aren't bad fractions. They're usually halves, thirds, quarters, and fifths. Because anything beyond that, we probably wouldn't be dealing with. So, here are some things that, again, you already know this. It's well, I won't say you already know it. This is stuff that I've already put out at the beginning of the year. These are the perfect squares and perfect cubes I expect you to have memorized. I specifically missed it. It's not that I missed it.
You missed it.
Because I don't require you to know it. As a memorized one.
Write it out? Yeah.
I expect you to know every power of 2. Or be able to come up with it quite rapidly. So 2 ways you can look at these numbers. The first way is that 4 to the 4th is 256, or that the 4th root of 256 is 4. Or 256 to the 1/4 is 4. Yes, Damien?
You wrote that x squared is 2.
Well, how about that? Maybe it is in some world, but not today. Okay.
Some lessons. No, today.
If it's one of these numbers going in either direction, whether you have this number and working backwards by taking its cube root, or having this number and going forward by squaring it or cubing it or something like that, these are ones I expect you to be able to do without a calculator. These are the questions that I would have that are on a no calculator portion of a test. Weird one, 11. 11 cubed. I'm going to show you guys how you can come up with powers of 11. What is 11 to the 0th? Anybody?
1.
Okay.
1. Oh, yeah.
What is 11 to the 1st?
11.
11 squared.
1.
Okay. Powers of 11 actually they follow a pattern here. The left-hand number is going to be a 1. The right-hand number is going to be a 1. And then the next numbers come from adding the 2 numbers above it. What's 1 plus 2? What's 2 plus 1?
3.
So 11 cubed would be 1331. If you wanted to do 11 to the 4th.
1, 4, 4.
No. First number's a 1. Last number's a 1. 4, 6, 4, 1.
Okay. That is cool.
11 to the 5th, it still works, but you got to realize that when you have things that add up to more than 10, you have to carry it to the next digit. But it still works for powers of 11. Later on this year, this pattern is also going to work for something else that we're going to do. So this pattern is very important in mathematics. It's very important in nature. It has a name. It's called Pascal's triangle. So it's very important in nature. It's very important in math. So these are the ones that I expect you to know cold. Okay? What's the cube root of 27? What number times itself
3.
3 times is 27? 3.
Yeah.
Okay, and that's the way you need to think about these problems. The numbers that I give you to take roots of are going to be ones that you should already know. Like the fourth root of 81. Well, I don't know what the fourth root of 81, but I know what the square root of 81 is, and that's 9. And what's the square root of a square root? It's a fourth root. So what's the square root of 9? 3. So you can reason yourself through these. So I'm going to erase Pascal's triangle. I'm going to leave these numbers on the board, and I'm going to work through some example type problems. And then get you set up on your homework. So first example would be 64 to the 4/3. Actually, I'm going to help you guys out here. X to the m over n. I can rewrite it two different ways. I can rewrite it as the nth root of x to the m. Or I can take the nth root of x and then raise it to the mth power. All three of those mean the exact same thing. This is the power, and this is the root. I will tell you right now, it is a lot easier to find roots of smaller numbers than it is to find roots of bigger numbers. So do I want to raise something to a power and then find its root, or do I want to find its root and then raise that root to a power? Is it going to be easier for me to find a fourth root of 256 or to find a square root of 16?
16.
Okay. So you want to find roots of small numbers. Okay? So which is going to be the smaller number? Raising something to a power and then taking the root, or just taking the root first and then raising it to a power? This is the one operations that you want to do on those fractional exponents. You need to take the root first. Remember when we do things multiplying by fractions, we simplify before we multiply? It's the same thought process. You want to deal with small numbers because these are things that you're going to have to do in your head. So, 64 to the 4/3. This is the cube root of 64 raised to the 4th. What's the cube root of 64? What's the cube root
4
of 64?
to the 4th is 16.
No, 4 to the 4th is not 16. 4 to the 4th is 256. You can do that one in your head once you have this list of required memorizations down. However, if you put 64 to the 4th in, you're going to get a big, huge, long honking number. And then trying to find the cube root of that in your head is not going to be fun. Okay? So take the roots and then raise that final answer to a power. Next example. What are we supposed to do with negative exponents?
Make the thing smaller.
No, what do negative exponents? How about x to the negative 2? What did I tell you to do last week with x to the negative 2?
To put it below the fraction.
And do what to the power?
Make it a positive.
Make it positive.
So you take its reciprocal and you make the exponent positive. You do the same thing here. It's the regular rules of exponents. You take the reciprocal and you make the exponent positive. That's the first step. And what's the cube root of 8? What number times itself 3 times is 8? You've only got 3 choices. 1, 2, and 3. 2. And the 2's on the bottom. Okay, cube roots. These 3 should be easy because they're on your regular multiplication table. That's 9 times 3. That's 4 times 2. That's 1 times 1 times 1. These 3 should be easy. Okay? Any power of 5 ends with the same 2 digits except for 5 to the 1st and 5 to the 0. If it ends in 25, it's probably a power of 5 or something that has a 5 in it. Every single power of 5 except for 5 to the 0th and 5 to the 1st ends in 25? 25, 125, 625, 3125. Okay, so if it ends in 25, think of it, it's probably got a 5 in it. With the exception of here, that 225 has got a 15, but 15 also has a 5 in it. That's 5 squared times 3 squared. Okay, going to do a couple more. 125 to the negative 2/3. First step is to do what?
Reciprocate it and make the exponent positive.
Okay, reciprocate it to make the exponent positive. So that's 125 in the denominator to the positive 2/3. And the way I want you to think about this is it's the cube root of 125 squared. What's the cube root of 125? 5. And what is 5 squared?
25.
So the final answer is 1/25. Any questions on dealing with a single number and simplifying a single number? But that's not where the power of these exponents come in. Where the power comes in is it allows me to do problems like this. (12 to the negative 1/2 times 12 to the 5/2. What do I do when I have the same base when I multiply things with exponents? You add them. Add the exponents. What is 5/2 minus 1/2?
That is 4 halves.
Okay, so that gives me 12 to the 4/2. And what does 4/2 simplify to?
2. So 144.
And you would have looked at this problem to begin with and say, hey, Mr. Taylor, I didn't have any fifth powers of this that I had to deal with for 12s. You didn't have to because it's simplified to a 4/2, which is 144. How about, let me erase that one. (6 to the 4/3 times 6 over 6 to the 1/3.
Wouldn't that simplify to 6 to the 1/3 over 6 to the 1/3?
No. Well, what's this exponent in thirds?
Doesn't that simplify to 6 times
3
6?
thirds.
This is 3/3. It does simplify to 6 times 6, but we're going to do it mathematically correct. We add the exponents that are on the top that we're multiplying together, and then we subtract the exponent that's on the bottom. What is 4/3 plus 3/3? 7/3 minus 1/3.
Which is 2.
Yes.
Well,
Wait, is that
Okay,
a subtraction or a multiplication dot?
That's a multiplication dot.
I thought it was a subtraction.
No.
Well, I thought it went to 1.
I'm not allowed to do it. Do you want
I need to see the work, yes.
Okay, we are.
And realistically, what I should have seen was 6 to the 7/3 over 6 to the 1/3 equals 6 to the 6/3. It's 6 squared, which is 36.
So,
If you just write 36 down, you're going to lose some points because I don't see the work that you're getting to 36 from. You need to show me something that's going to justify that 36. Now, you probably looked at this and say, hey, if I take a third away from that, I got a whole.
that's what.
And then I got a whole. Okay?
That's what I did. Is that okay?
On a standardized test where you don't have to show your work, yes, but on a test in this classroom where I require you to show your work, if you explain the way you did it in words, why don't you just do the math for me? Say 4/3 minus 1/3 is 3/3, which is 6 times 6. Show me the work.
Okay.
So you could have showed me the work your way and just taken this one minus this one and then multiplied it by the 6. Yes?
But in the future, when that doesn't work out, you're going to want to know.
Yeah, I'm going to want to know, yes. So again, this is dealing with the same base to various powers. Notice this thing I had here that was the case was I was able to come up with the same exponent really easily, the same fractional exponent. Where things become more fun.
Yay.
8 to the 4/3 times 8 to the 3/2. When you have two things to the same base that you multiply together, what do you do with the exponents?
You add them.
You add them.
So we're going to add them together.
So I'm going to have 8 to the 4/3 plus 3/2. Well, in order to add fractions, I must have a common denominator. What's the common denominator between halves and thirds?
6.
6.
6.
What do I have to multiply 3 by to get to 6?
2.
So multiply top and bottom here by 2. What do I have to multiply 2 by to get to 6?
3.
So multiply top and bottom here by 3. So that's 8. 4 times 2 is 8. 6. 3 times 3 is 9. 6. What do I have here? 9 6 plus 8 6 is?
17 6.
Okay. This is the only time in my math class that I desire you to turn improper fractions into mixed numerals. What is 17 6 as a mixed numeral? 2 times 6 is 12. 17 minus 12 is 5. So I get 2 and 5 6. The word and in math usually means addition, right? Mm-hmm. The 2 and 5 6 comes from 8 squared plus 8 to the 5 6. I don't know how to take the 6th root of 8. Okay? But I have a perfect power of 8 here. What's 8 squared? 64. So my final answer would be 64 times 8 to the 5 sixths. That would be the final answer. That is the final answer that is not a decimal. That is the final answer that I would expect you to be able to do without a calculator. If I wanted an approximate number, you could have just put 8 to the 17 sixths into the calculator. But a lot of these I'm not going to want approximate numbers. I'm going to want exact numbers. Using this fractional exponent thing is how I can also go about writing this most simplified form of regular roots. Now that we have our magic board here, it's gone. You've had enough time to stare at it.
You just demagic the board.
It's okay. Square root of 24. I want to write that in simplified form. Do you know any perfect squares that go into 24? Does 1 go into, well, besides 1, does 4 go into 24?
Yes.
Is 4 a perfect square?
Yes.
So do you know a perfect square that goes into 24?
No.
Does 4 go into 24?
Yes.
Is 4 a perfect square?
Yes.
Do you know a perfect square that goes into 24?
No.
Okay, for those that are watching this at home, they just failed the test that I just gave them today. And you guys can continue, and yes, we do know a perfect square that goes into 24.
Joking. Not joking.
Do you agree with that?
Yes. All 4 of us failed.
That would be the simplified form of that. 2 root 6. I'm going to do this one. This is the way I would have expected you to do that day 1 of school this year. Because this is something that you should have carried over from middle school. More than likely, you never covered it in middle school. That's why I have not talked about it yet.
We did not cover that.
But let's factor 24. Well, that's 2 times 12, right? Oh, that's 2 times 6, isn't it? And isn't that 2 times 3? So isn't this 2 cubed times 3? So I'm going to take the square root of 2 cubed times 3 to the first, which is 2 to the 3/2 times 3 to the 1/2. Do you agree with that?
Yep.
How can I write 3/2 as a mixed number? How do I write 3/2 as a mixed number?
One half.
So I could rewrite this as 2 to the first times 2 to the 1/2 times 3 to the 1/2. Does everybody agree with that? If I'm raising something to the 1/2 power, that is the same thing as doing what to it?
Just leaving it.
No, sorry. D
To the 1/2 power. It's
depowering.
What's depowering? What's the R word that we use for depowering? No. Roots. That's the square root. Raising something to the half power is the square root. So that gives me the square root of 2 times the square root of 3 here.
5.
What's the square root of 2 times the square root of 3? The square root of 6. Times 2 to the first, which is just plain old 2. Notice I got the exact same answer either way I did it. But you can see, using the fact that roots are fractional exponents, when you do the work of raising the power to the root, this has meaning now. This is 1.5 2's. So 2 to the first plus the root of 2. So that has meaning for you to write it in its simplified form.
2 times 2.
Now, the way I do it is the top way, because it's really easy for me. For any number that's less than 100, I can tell you what its perfect square root is easily. Because all I have to do is I try to look for perfect squares that go into those things. Okay? I need to know what my powers of 4, what my 4's are on my multiplication table. I need to know my 9's on my multiplication table, and I need to know my 5's on my multiplication table. I only need to know 6's twice, 7's twice, 8's twice, and I got to be able to do some simple arithmetic. Do you know any perfect squares that go into 52? 2 is not a perfect square.
Hold on.
I know there's 7 squared.
Does 49 does not go into 52, I will guarantee you that. Well, it does, but not evenly.
8?
Is 8 a perfect square?
Yeah.
No, it is not.
Fine.
What two of the same number do I multiply together to get 8? 8.
Wait, what?
Yeah,
What did you
perfect.
say? That's not
I
a thing.
answered the same question you did. What two of the same numbers can I multiply together to get 8? 4 times 4 is not 8.
2.
Yeah, but they're not the same number.
What did you do with 3 times?
Perfect squares.
Perfect square.
4 goes into here.
I said 4.
I just said that.
No, you said 8.
I said 4.
I said 4 times 2.
Not 4 times 2.
Right, but you said 4.
No, 8 does not go into this. No, you said 8 goes into here. 8 is not a perfect square. And 8 doesn't even go into this. 52 divided by 4 is 13. What's the square root of 4?
2.
2.
Is that the final answer?
Yep.
Yeah, that's the final
Perfect
answer.
square that goes into 28.
Hold on.
4.
Let me look.
4?
Okay?
4 is like always there.
No, it's not always going to be there. So it's 4 times what is 28?
4 times
7. Square root of 4 is,
2.
and I got 2 root 7.
That's so easy.
That's because it's just 4s.
You stop. So, like, are these going to be on our homework or what?
Mm-hmm.
Yeah.
Is that what we're writing down the answers?
Perfect square that goes into 75.
4? 5.
5's not a perfect square.
I know. Okay.
What's the square of 5? What's 5 squared?
25.
That's what I'm asking for. I'm not asking for 5. I'm asking for the perfect square that goes into this. I'm looking for 1. Actually, I don't care about 1 because it doesn't simplify it. I'm looking for 4s, 9s, 16s, and 25s.
Oh, that's 25.
25 goes into here.
Oh my geez.
So it's the square root of 25 times the square root of
3.
What's the square root of 25?
5.
Math is easy.
Mm-hmm.
It's easy after
All
an
things
hour of assembly.
So, we're going to go back to elementary school. What is 4 times 1?
4.
4 times 2?
7.
8.
4 times 3?
12.
Next?
16.
Next.
24.
Oh heck.
It's not 24.
Oh,
and it's
wait.
not OHEC.
26. It's 20.
24,
sorry.
28,
32.
32.
We're going to stop there.
36.
What's the square root of this?
2.
That's
4. No.
Yeah, you should do those.
Oh,
Let's say
so
14.
it just adds a. Oh, that's crazy.
actually it's the other way around.
Oh,
Silly
wow.
dudes.
I like it.
So it
2,
just
4.
adds.
Oh, that's 2,
another
3.
to the
2, 4,
square
2, 5. Oh,
counter.
sorry.
Why'd you have to put that equals 4 in that 1?
Because what's the square root of 4?
4?
Square root of 4.
2.
2 times 2.
You're done.
Okay, now watch this one. I have the square root 2 times the square root of 8. What was the square root of 8? 2 times the square root of 2. So what is 2 times this? 4 root 2. See a pattern. What did I do over here? Well, isn't this the same thing as 2 times the square root of 1?
Yeah? No. Yes? No.
I don't like
So anytime you see a number that is one of your numbers from your multiplication table from elementary school, that's multiple of 4, you know it can be rewritten as something with 2 times the root of something.
Well, pretty much the power, well, anything that 2
54,
goes into.
63, 72, 81, 90.
This would be 3 root 1, 3 root 2, 3 root 3, 3 root 4, but what's the square root of 4?
2.
2 times 3 is?
6.
3 root 5, 3 root 6, 3 root 7, 3 root 8, but the square root of 8 is 2 root 2. What is 3 times 2?
6?
So I have 6 root 2.
Yeah.
This is 3 root 9, but what's the square root of 9?
9.
3 times 3 is?
9.
And this would be 3 root 10. Same thing. Any of your powers of 9 on your multiplication table, not powers of 9, any of your multiples of 9 should be really easy for you to come up with a simplified form. Any question on those 2 topics that I covered? The 2 topics I covered are the use of fractional exponents and then how to simplify simple roots. Okay, your homework comes in 2 parts today. First part is page 456. 1 to 12 all.
Oh my gosh, it's so mean.
It's like 11.
Okay.
It's 12.
It's like 13.
Oh, it's actually, you did I wonder if we can recording. Yes, it is.
Should be the bloopers.
Quiet, please.
Thank you.
In the second part,
All the people that skipped
we're not going to do. We're going to just do that for now. But I do expect when I want answers in simplified form, it's like this for roots. That'll be your homework for today. You should have almost enough time to finish 12 problems.
Thank you, Mr. Taylor. That is not